All right, so inscribed quadrilaterals, that's going to be a quadrilateral inside the circle. There's a couple of rules that happen when we do that, okay? So the first one is that the opposite angles of the cyclic quadrilateral are supplementary. You remember what supplementary means? Yeah, they add up to 180 degrees. So opposite angles inside the quadrilateral have to add up to 180 degrees, okay? The other rule that happens is that an exterior angle of the quadrilateral is equal to the interior opposite angle. So if you extend this line out right here, that would be the side of one of the quadrilaterals, and you take this angle that's right here, we're going to call it X, it's going to be same as that opposite angle. So if you're looking at which angle would be right here, you're going to find the opposite angle to that, and it's going to be the same as that, okay? Just a reminder here too that if you knew this angle right here, couldn't you just subtract it from 180 to get that angle? Like, all rules that we've known still apply. So this time we're just putting a quadrilateral inside of a circle, which, why would we not do that for fun? Right? Right. Okay. All right, first example says find X and Y. So we have a quadrilateral here. Does anybody remember what the rule said about opposite angles? So angles that are clear apart from each other, they're supplementary. What does that mean they have to add up to be? 180. So what's X going to be?
72.
X is 72. Because they're supplementary, they have to add up to 180 degrees. Would you guys agree with me that this angle and this angle are opposite angles also? They're on complete opposite sides of the quadrilateral. So they have to add up to be 180 degrees. So what does Y have to be? 92. Because what we did was we took 180 and we subtracted 88 from it, and we got 92. So far, is that rule hard? No, that rule's pretty easy, right? Okay, another time here, same rule, different quadrilateral. Opposite angles are supplementary. So if this one's 70, what's that one going to be? Yeah, it's 110, because you would have to do 180 minus 70 to get that one. And then what's this one over here going to be? That one would be 180 minus 60, which is going to be 120. Okay, you following me on this rule? How easy is that rule today? That's easy, right? It doesn't get much easier than adding something up to be 180. Okay? Until we throw variables on them instead. Then it gets a little bit more difficult. So here we're going to try the same exact rule, but we're going to use it with some variables, okay? So when we look at these right here, we're going to find X and Y. So what do we know about opposite angles? They add up to be 180 degrees, right? Here's a problem though. I have an X here and I have a Y here. Same thing happens when you use those opposite angles. You have an X here and a Y there. So if we're going to solve this, it looks like we're going to have to use a system of equations. This is like from forever ago math. Who thinks we can remember how to write a system of equations and solve them? Anybody?
Sure.
Sure. What do these two have to add together to be? 180. So let's just combine them like terms if there are any. We're going to have 2x plus 17y plus 61. You guys agree with me on the 61? Because a positive 62 minus 1 would be plus 61 equals 180, right? Because we said they had to add together to be 180. You guys following me on that? Okay. Let's do these two. and write an equation for that. I'm going to write it in the same order I did this one, right? Because I want to be able to do stuff with the equations. So I'm going to go x, how many y's? Yeah, plus 12y plus 96 equals 180. Okay, I'm going to simplify those two equations because really can I subtract that 61 over to the other side so that I can have my equations in a way that I can kind of deal with them better. So I'm going to take this first one over here and I'm going to subtract that 61 over to the other side. So I'm just going to rewrite it so you guys don't lose what I'm doing here. I rewrote it and I'm subtracting the 61. So when I do that, I get 2x plus 17y equals 180 minus 61 is 119. Yeah? All right, I'm going to do the same thing with this equation. I'm going to write over here, though, so I don't get confused where I'm at. So I have x plus 12y plus 96 equals 180. I'm going to subtract that 96 over to the other side. So I get x plus 12y equals the 84. I don't know, you guys. Do the math for me. 94? Thank you. Okay, I have two.
It can't be 94 because 90 plus 90 is 180.
Yeah, so 84?
It has to be 84.
Oh, well, I was right, huh? 84. Thank you. Okay. I have two equations here now. Does anybody remember how to solve two equations at the same time? We had two methods we could use. We could use the substitution method, or we could use the multiplication addition method. It's called the elimination method, where we multiplied one of the equations through by a number and added them straight down. You guys remember that method? That's my preferred method. So I'm going to stack these up, and I'm going to remind you of that method that we used. Like, it seems like forever ago, but this is a really good review problem to see if we can remember what we did. So do you see how all I did was rewrite my two equations on top of each other? One equation here, one equation here. I rewrote them on top of each other. Now my goal is to be able to add these suckers straight down so a variable will cancel. Will they add straight down right now so a variable will cancel?
Yeah.
I would get 3 here. I would get 29 here. So not canceling, right? But what if I could get this x to have a negative 2 in front of it? Do you remember multiplying through by a number to get the whole equation to cancel, or part of the equation to cancel? So I'm going to multiply this entire equation through by a negative 2. Okay? Yeah, because I want the positive 2 and the negative 2 to cancel each other out and get rid of that x variable. Okay? So when I do that, I get negative 2x. Then how many y's?
24.
Yeah, negative 24y. Make sure I write that right. And then that will be equal to negative 2 times 84, which is negative 168. You guys remember how I like to draw a line through that one to remind myself not to use it when I'm adding straight down? Is this method coming back to you now? No, you're like, no way. I'm going to add those equations straight down and see what happens. What happens when you do 2x minus 2x? Cancels. That's why we did it, right? I have 17y minus 24y. Negative 7y. And 119 minus 168. Negative 49? That's nice because that worked out really nice, didn't it? What do I do now? Last step? Divide by negative 7. And I get y equals 7. That was a lot of work to find y. I'm not done yet because I still have to find x. So here's how I'm going to do this, because if I substitute my y value in here, won't I know this angle right here?
Yes.
Let's substitute it in and see what happens. 12 times 7 minus 2, how much is that?
82.
It's 82. This angle measures 82. What do I know this one and this one right here add together to be?
180.
Yeah. So could I go 82 plus x plus 98 equals 180 if I wanted to solve it that way? Really, Mrs. Clark would have just done this in her head. She would have been like, if this is 82, this one has to be 98, right? So what's my x value got to be? 0. You seeing how that will totally work? Will my equation solve that same way? What's 82 plus 98? 180. So I would have x plus 180 equals 180. What does my x have to be? It has to be 0. So either way you do that, you would have got 0 for your answer.
That's literally so much work for one problem.
That really was a lot of work for one problem. Yeah. So the worksheet does not have any on them that are this hard. Really the point being is that hopefully when on the worksheet, and they should line up, that your x would be with your x so that you can just add them together and equal them to 180. But I actually really liked this problem because it's a really good review problem of a lot of math that we did earlier in the year. And if you guys remember, we have a big test coming up for those of you that are not 11th graders, right? You have to take the end of level test next week. So good problem to review. The state of Utah's end of level math test. Those of you that are not 11th graders will be taking it. Yeah, 10th graders and 12th graders. All right. Here's the last, is this the last question or is there stuff on the back? Oh, there's stuff on the back. Okay. Can this quadrilateral be inscribed in the circle? So we know if it's going to be in the circle, what do we know about the opposite angles? They have to add to 180. So do my opposite angles add to 180? No. So can this be inside of a circle? No. So to figure out whether or not a quadrilateral can be inscribed in a circle, you're going to see if they can add to 180, if the opposite angles add to 180. If they do add to 180, then they are going to be, that quadrilateral will be able to be inscribed in a circle. If they don't add to 180, then it will not be able to be inscribed in a circle. Does that make sense to everybody? All right, another problem here. We're finding x and we're finding q. So this angle and this angle. Does anybody remember how I told you you could find this outside angle right here? It's equal to the opposite angle. Here's my opposite angle right here. So what's that outside angle going to be? 102. That wasn't too bad, right? X equals 102 degrees. Then I need to find Q also. Help me walk through this. If that outside angle is 102, what's this inside angle right there? It has to add to 180 because it's on a straight line together, right? So it's going to be 78, right? I also could have figured that out because opposite angles inside the quadrilateral have to add to 180. So I could have figured that one out by subtracting 102 from 180. Now this one right here, if this is 92 and this is on a straight line together, can I subtract 92 from 180 to get that inside angle? So what's that inside angle? 88. And then what do we know about, we could go opposite angles here. What do they have to add up to be? 180. Or you could use a rule that said all four angles in a quadrilateral add up to 360. It should be the same answer either direction. But what do you get right here? 92. Okay. Questions on how we did that? All right, one more. Find an opposite angles inside this quadrilateral that's inside the circle. We know opposite angles add to 180. So what does that one down there have to be? 74. Good. And then if this is 74, this is 87, that's 106. You could add them all together and subtract it from 360. Or you could use that rule again that we know that opposite angles add to 180. So if this one's 87, this one has to be 93. Questions on how to use that rule today?